In this section, we're going to talk about a tool that is becoming increasingly popular in JavaScript land, TypeScript. What is TypeScript? Before we understand that, we must first learn about the types of programming language that we have. That is, because TypeScript changes one of the fundamental concepts of JavaScript. It makes JavaScript, which is a dynamically typed language, into a language that is static typed. What does that mean? In this section, we're going to learn about the idea of static typing versus dynamic typing. We'll show you some of the tools that allow us to use static typing, which might be useful, and also talk about some of its downsides. We're then going to learn TypeScript by actually writing it. And we're going to finish off this section by actually adding TypeScript to our RoboFriends app. And at the end, we're finally going to be able to tell Bruno what we think of TypeScript and whether we should add it to our RoboFriends project or not. It's going to be another fun one. So let's get started and see you inside. Welcome back. There are a ton of programming languages out there. We've heard of them, right? Python, Ruby, Java, C++. There's a ton. And although JavaScript is the dominant language on the web, and with the introduction of things like Node.js, we can now use JavaScript outside of the web, perhaps in the backend server as well. The world still has many different languages that are suited for their own domain and ability. And if we had to categorize all these programming languages somehow, we would probably do something like this. In this video, we're going to talk about the main spectrum here, the dynamic and static of how programming languages can differ. Dynamically typed and statically typed. We see over here that JavaScript is a dynamically typed language, and so are other popular programming languages like PHP, Ruby, Python, Clojure. On the other hand, languages like Java, Haskell, Scala, C++ are static or statically typed languages. But what does that mean? Well, let me actually just demonstrate it for you. If I open up the console here, and oh, that's a nice background today. Anyway, back to the console so we can type some JavaScript. In JavaScript, because it's dynamically typed, we can do something like this. Variable a equals 100. All right, that's pretty expected. We know how JavaScript works, and that's fine. But in some languages, this wouldn't work. You see, a dynamically typed language allows us to not have to say what type of variable this variable a is going to be. What does that mean? Well, in a statically typed language, let's say we were writing C++, which is a statically typed language, we'd have to do something like this. And I won't get highlighting because, well, this browser won't recognize C++. But if I was about to do the same thing, I would have to say int a, and int stands for an integer. And then on a new line, I'll say, let me add a semicolon here. And on a new line, I'd say that a equals 100. You see, with a statically typed language, I have to say what kind of type this variable is going to be. In this case, it's an integer. If this was a string, like a hello, I'd have to say string, and so on and so forth. So with a statically typed language, we have to declare the variables explicitly before using them. Dynamically typed languages are not bound to this constraint. They're not bound to a particular type. JavaScript is smart enough and it's going to say, Oh, yes. Variable A, that's 100. Oh yeah, that's an integer. It's an integer type. Wow, I'm so smart. That's what JavaScript is saying. And in dynamically typed languages, type checking is done during runtime. What does that mean? Well, if you remember in our discussion about the browser performance, JavaScript gets run on the browser in the runtime or in JIT or just-in-time compilation. While the user is actually browsing through the website, JavaScript is running and being compiled in the background. If you remember our performance tab, we had our scripting performance metric, which was that yellow pie graph, or the piece of the pie graph that was yellow, that included the compile of the JavaScript as well. And because of that, we're able to use dynamically typed languages that can assign anything to any variable, and you're not going to be caught. You might get errors during runtime while the user is browsing your website, but because of this, we're able to just not have to worry about this. Looks pretty nice, right? Why would we ever want to do this? This is just so much cleaner and easier for us to write. Well, we're going to see why that might not always be ideal and why it might cause a problem. But before we get to that, there's been a holy war going on in programming languages. People that think statically typed languages are the way to go and think dynamically typed languages are horrible, and vice versa. People that say, oh, statically typed languages are a waste of time and dynamic programming languages are the way to go. Because of that, I'm treading lightly on this topic because people are so opinionated. They have such strong opinions about this. But again, as senior developers, let's not focus on what is right, what is wrong. Let's focus on pros and cons, when one is good over the other, so that we can make smart decisions. Let's talk about the pros. The number one thing with a statically typed language like this is that we get documentation. Perhaps a better way to demonstrate this is to actually write a function. If, let's say, I was going to delete this and say function sum, and in this sum here, I'm going to use a bit of a syntax that might not be familiar to you, but for now, it's fine. We'll just assume that this works. We'll say A is a number, and B is also a number. And in here, we can just return A plus B and close our function bracket. This is in JavaScript. If we ran this, we're going to get an error. But this demonstrates what a statically typed language could do. You see, if a new developer came along and ran the sum function with something other than a number, let's say that they ran the sum function with sum hello and maybe something null. Well, this, before we're ever even going to put this code on the browser or in production, is going to error out because it's going to say, you're doing something wrong here. I'm expecting a number and a number here, and you're not giving me any of that. And in that sense, statically typed languages are self-documenting. That is, I can come onto a project and immediately see that even if this was named badly and this was a complicated function, I can see what kind of parameters it expects, and I avoid making that error. The second pro of a static typed language is that because of this feature, with our IDEs or text editors like Sublime or Visual Code or any of your favorite text editor, this helps with autocompletion in your editors. You can download plugins that say, hey, even before you run this, this should be a number. That's also really nice when you're developing. Finally, the most important thing, and yes, there are many more pros, but we're just focusing on the main ones here. The main thing of statically typed languages is that you're going to get less bugs. You're going to get less bugs in production because this will never make it into production. If this fails at what we call compile time, that is, before we even send it onto a browser, then we catch that early. We catch those bugs early so that in production, most of the time, there's going to be less bugs with a statically typed language. And don't worry, we're going to talk about compiling and how that works later on. Now, that sounds pretty great. Less bugs, easy documentation, helpful auto-completion in editors. So why don't we just do a statically typed language? Well, there's some cons. Number one is that we obviously just made our code a little bit more harder to read. It's more complex now. We're just adding another layer to our programs. And this takes time to learn. If we have our project and we have new people joining our company, we're going to have to teach them how to write more code and how to write this properly. It's an extra layer of complexity. And that's always a concern with programming, right? Adding an extra layer of complexity, is that really going to benefit the project? The other cons or argument against statically typed languages is that, well, why can't you just write better tests? A topic that we cover in another section. Many people get very, very excited about static typing and forget about writing good tests, good unit tests. Before you have static typing, especially in a language like JavaScript, make sure that you have good unit tests and you don't forget about writing unit tests and assume, oh yeah, just because I have static typing, I'm not going to get any bugs. That simply isn't true. Finally, with a statically typed language, you're going to have a slower development process because you now have an extra step where while you're coding along, there's also another check to see that you're not making any type errors. And this actually just slows down the development process and how fast you can create code and run code and ship it to production. You see, with dynamically typed languages, and this is why JavaScript was so popular, is that you spend less time debugging syntax and semantic errors like this, and instead, most of your debugging time is spent purely on logic and errors, which as a developer are a lot more interesting. All right, let's go back to this. There are a few other pros and cons, and everybody always has opinions when it comes to these two topics. But the main point is this. Static types usually prevent bugs and help keep errors from happening. Dynamic typing allows you to be more flexible and write software faster. TypeScript allows us to make JavaScript to behave like a statically typed language. It adds types to JavaScript. So it makes JavaScript extra safe. But before I go on and show you a demonstration of how TypeScript works, let's talk about the other two parts of this graph that often get confused with dynamic and static typing. I'll see you in the next one. Bye-bye. Let's talk about strong and weak typing. And a lot of people tend to use these terms interchangeably. That is, they tend to say, oh, a dynamic language is weakly typed and a static language is strongly typed, which simply isn't the case. As you can see here on the graph, you can have a weak language that is statically typed and a strong language that is dynamically typed. So let's make this clear. JavaScript is a dynamic language or dynamically typed language that is weakly typed. What does that mean? Well, in JavaScript, I can do this. In JavaScript, I can say variable a equals booyah, and then I can go ahead and say a plus 17. Booyah with 17. That's what a weakly typed language does. JavaScript says, you're crazy. You're trying to add a string to 17. I think I know what you're trying to do. I think you're just trying to add 17 to booyah. So I'm just going to turn this 17 number into a string and do this. And this is often called type coercion in JavaScript. And it can lead to some unintended consequences, and a lot of people get annoyed at JavaScript for this feature. Because in a strongly typed language, you can't do this. For example, in Python, you can see that it's dynamic, but strongly typed. If we write some Python code, let's say I'll do, and I'm just going to use Python here, ignore the syntax. So let's say variable is equal to booyah again. And then I'll do a or variable plus 17 here. Well, this is actually going to throw an error in Python because it's going to say, whoa, 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 you crazy guy. You're trying to add string and numbers. That doesn't work. And it's going to throw an error because it's strongly typed. All right, I hope that illustrates the point nicely for you. Now, there are once again pros and cons to doing this, but this is beyond the scope of this course. If you really want to get into it, and trust me, there's tons of information out there because people are so strongly opinionated about these topics, I do recommend checking them out, going on Google and typing strong versus weakly typed. Let's get back on track here to our main topic, that is TypeScript. How can we add TypeScript to make JavaScript type safe? All right, I'm going to leave you in suspense. I'll see you in the next video. Bye-bye. All right, welcome back. Let's finally get into things and talk about TypeScript. Now, why did I pick TypeScript? Because there's actually many ways that we can introduce static typing to JavaScript. There's tools like Flow, Elm, ReasonML, and obviously TypeScript. For example, ReasonML and Flow were created by Facebook and the developers at Facebook, and TypeScript by the fellows at Microsoft. But they all do the same thing. They all try and make JavaScript a statically typed language. Now, let's talk about ReasonML. Reason is based on a programming language called OCaml. And like I said before, it's created by Facebook to make it easy for JavaScript programmers to pick up. It's a language in its own, but similar enough to JavaScript that it's easy to pick up. And Facebook actually uses it with some of their projects. And currently, 50% of their messengers front-end code is written with Reason. So that's a popular language coming out of Facebook. All right, but again, I'm still not getting this. What does this all mean? Well, maybe the next slide will help you. Again, all of these tools, their goal is to make writing JavaScript a little bit nicer, a little less buggy, and introduce static typing. And Flow, which is used very commonly with React projects, is what we call a static type checker. Let's start off with this one. Flow is able to add types to our JavaScript by writing some code that works with Flow and then putting it through a compiler, such as the Babel compiler, which spits out JavaScript. And we know what Babel does from previous sections. It takes ES6 code or ES7 or ES8 code and changes it into ES5 code so that all browsers can understand it. Now, Flow is a static type checker, which means we're actually writing something like this at the top of our files. At the top of our files, we'll do something like -- @flow, and Flow is going to be able to say, this file has flow types, and I'm going to check it for you. It checks the types. Again, don't worry, when we talk about types, you're going to learn them in later on videos, but again, we want to build the foundation first. If you go back here, what we actually do with Flow is that it checks everything and it relies on Babel to actually remove that add flow and all the other types that we've entered into our code before production, before sending it to our users. And flow actually comes pre-built into Create React App. If we go to the flow documentation at flow.org, we see that in Create React App, we simply run these commands and we can start writing type checking in our code. Again, something that we'll cover. TypeScript differs from Flow because TypeScript has its own compiler. It's not like Flow that depends on Babel to remove all this extra code before spitting it into JavaScript that we want to send to the front end. TypeScript is what we call a superset of JavaScript. That is, it adds functionality on top of JavaScript. That means that JavaScript is TypeScript. And TypeScript just simply adds a few extra features on top of JavaScript. But it also has its own compiler. So we write TypeScript code, which then gets run through the compiler. And remember, a compiler is just simply a machine that takes an input of some piece of code and outputs a different piece of code. In our case, we're going to convert it from TypeScript to JavaScript that our browsers can read. Just like I talked about before about ReasonML, it has the same thing, its own compiler, and it's going to go through the compiler and spit out JavaScript code. The difference between TypeScript and ReasonML is that Reason is a completely separate language from JavaScript on its own. TypeScript tries to mimic JavaScript and grow with JavaScript. Like I said, it's a superset. But ReasonML is just a whole different language on its own. It doesn't depend on any JavaScript changes being made in the ecosystem, any of that. And Elm is pretty much the exact same thing as ReasonML. Its own language that is type-safe, that has its own compiler and spits out JavaScript. So you might hear in JavaScript land people using these tools. The ones that you should really focus on, because Elm and ReasonML are still fairly new. You won't find that many jobs out there that actually request it. It is nice to learn and interesting, but again, most of the time you're looking at either learning Flow or TypeScript. Now, the reason I'm teaching TypeScript instead of Flow in this course is that the growth of TypeScript outweighs all of the others that we've learned in this section, all these ones. Now, a big part of this is that Angular is built with TypeScript and using TypeScript. So if you're an Angular developer, you're already using TypeScript pretty much by default. However, a lot of the React community is also starting to use TypeScript, and just general JavaScript community is starting to get more and more used to using this. And although Flow was created specifically to work with React, TypeScript currently is overtaking its popularity. So we wanted to learn this instead. Plus, once you learn, just like with most things, once you learn the WOM method, it's quite easy to pick up Flow and how static typing works in Flow. By the way, if you don't trust me, if we take a look at Stack Overflow developer survey from this year, we see that the most loved languages, well, we have Rust, Kotlin, Python, we have JavaScript in there, but you see TypeScript because it's its own language. I mean, it's a superset of JavaScript, but it's up there. It's very, very loved. And it's also quite high in the wanted section. So it's very, very important. And if you look anywhere, everybody's really excited about TypeScript. One quick note, by the way, why do you think Angular is such a big fan of TypeScript? Now, this is just my opinion. I may be wrong, but if you remember, I said that Angular is kind of like the kitchen. It's great for big companies like banks to make sure that their massive developer teams work within a kitchen that has already everything defined of how to cook bread or how to cook an app. TypeScript adds static typing, which adds an extra layer of security or an extra layer of type safety in the code. Again, expanding that kitchen to make sure that the codes or the coders, the developers on the team, play within the rules. I think that's pretty interesting. So let's get back to the topic at hand. As developers, we must understand why we put things into our projects. We don't want to just follow the trend because I just showed you the developer survey and everybody's using TypeScript and just jump on the latest bandwagon. As senior developers, we must decide for ourselves what works for our project and our team and what makes sense. So here's my outline of when to use static type checking like TypeScript. Your project grows larger and larger. You already have tests written. And as more developers join the team, you want the code to be self-documenting and also avoid bugs as new people touch the code. You also have the budget within the company to train new employees to learn this new language. And expect that our development cycle, that is how fast we're able to write features and new code, is going to be slower because we're writing more code now. That's your checklist. If that's the case, then we should add TypeScript. If not, we shouldn't. But in order to really understand it, we actually have to write TypeScript and go through the process. So let's finally get into coding. I'll see you in the next video. Bye-bye. Welcome back. It's time to set up our environment to work with TypeScript. Now, as with anything that I mentioned in this course, I do recommend you check out their documentation. They have really, really good information of what you can do, what you can use. And if we go back to what it says, we've now learned what this statement below means. TypeScript is a typed superset of JavaScript that compiles to plain JavaScript. So let's download it. And we could click here, but for me, we're developers. Let's use the terminal. Let's make this a little bit bigger for you. In order for us to work with TypeScript, we have to make sure that we have Node installed. And I'll leave resources for you to install Node after this video. But a good way to check if you have Node available on your computer is to do -v. I have 8.9.1, and you can follow along and make sure as long as your version of Node is higher than this, all the code should work. Now, why do we need Node to work with TypeScript? Well, if you remember in our diagram, TypeScript has this little machine, this compiler that compiles our code to JavaScript. And this compiler needs to run somewhere. And this compiler, again, has to have an environment. And that's what we use Node for being able to run JavaScript, because it has the JavaScript engine, that is the V8 engine that actually comes from Chrome, to actually read our JavaScript and understand it. So let's download this compiler. All we need to do is run npm install -g for global. That means we can use the TypeScript command now in our terminal and just type TypeScript. And based on your permission rights, you might have to run this with sudo. So that is giving it permission to install. You might have to type in your password. And then you'll get TypeScript downloaded on your machine. Perfect. Nice and simple. Now we're able to run TypeScript from our terminal. And the way we do that is do tsc for TypeScript compiler. If I press enter here, let's make this a little bit bigger. You see that it gives us all the information we need. I have version 2.8.3, and it tells us how we can work with this compiler. So now that we have the compiler installed, we can start writing TypeScript, put it through this compiler, and this compiler is going to spit out JavaScript. And through that method, we're able to add static typing to JavaScript, something that JavaScript doesn't have naturally in its definition. All right, so go ahead and get this set up on your machine. I'll leave resources for you to follow along so that for the next upcoming videos, you're typing along with me and testing out that your TypeScript compiler works and that we're writing TypeScript together. I'll see you in the next video. Bye-bye. All right, now that we have our compiler installed, let's see how we can start using it. I'm going to clear this and make this a little bit bigger so you can see. All we need to do to create a TypeScript file is to have a .ts at the end of the file. Just like we have .js for JavaScript, all we need is a TS file, and that is a TypeScript file. So let's do that. Let's make a directory first. We'll call it type. All right, I already have it made. We can cd into that folder. Oh, not to make directory. We want to cd into type. And in here, we can do touch TypeScript.ts for a TypeScript file. Let's open that in Sublime. And we have our TypeScript file. And again, I have a nice little plugin that gives me a types or a TypeScript icon over here. And it's already detecting it. Now, to get your editor set up to understand TypeScript, you might have to Google around and say, how can we add TypeScript to your editor? And I'm going to leave resources for you to do that as well. For Sublime Text, all you need to do is do Command-Shift-P on a Mac. You might have to do Control-Shift-P on Windows. You do install packages. And then within install packages, just simply do TypeScript. And I've already installed the package, so you see that it doesn't show up here, but it should just be the simple TypeScript package. There's a few others that you can download, but the simple TypeScript one should do just fine. Once you do that, if you go to the bottom over here, you see that my editor recognizes the TS file as TypeScript. And that's how you can check that your editor has those syntax highlighting for it. Again, you can see that I've got TypeScript all set up. Perfect. Let's write a simple TypeScript line here. We're going to go back to our simple example of function sum that takes in A and B, and it's going to return, let's say, A plus B. A very simple function. I'm going to save this, and let's run this through the compiler. Let's bring up the terminal. I'm going to actually just put this on one file just so it looks nice. And in here, we can run tsc for TypeScript compiler, and the file we want to run the compiler on. In our case, the TypeScript.ts. So TypeScript.ts. Let's hit enter. While I've been coding along, you may have noticed that, why did I just write an error function? And again, TypeScript detects these errors. Anytime you enter invalid JavaScript, it's going to be, on line 1, you're doing something funny. What are you trying to do? So again, let's write proper JavaScript. So this one is just a function declaration. So let's save and run that again. All right, that was it. No errors, but you see here that the TypeScript.js file was created. And if I go to TypeScript.js, all right, I have the exact same output. This function went through the compiler and it got compiled to JavaScript. Well, nothing is really different because we didn't do anything different here. All right, so let's turn this into a arrow function. Let's just say const sum equals arrow function and run it through the compiler again. and looks like there's no errors. So let's go back to our JS file. And whoa, look at that. It's changed our JavaScript or our TypeScript to a JavaScript file, but it's using the ES5 syntax. So no error function here. And you might be wondering to yourself, doesn't this what Babel do? Well, let's go to Babel. I'm going to open up the browser and say Babel and go to the Babel compiler. And they have a nifty little tool here that says just try it out. And right here, we can actually just run what we've done here. So let's just copy and paste our error function and see what we get. If we click on env preset, we see that we're getting the same thing. It's compiling down our new ES6 code to ES5. So yeah, it's doing the exact same thing as Babel. And this is another way to try new features of JavaScript and still compile it down to something that a browser understands. And now it might make sense why TypeScript is a superset of JavaScript. TypeScript allows us to use new features that JavaScript otherwise wouldn't have, and we just get to compile it. TypeScript also tries to stay in line with modern features of JavaScript, so they'll actually implement it so that the compiler understands arrow functions as well. Very cool. Now let's write our first type. The syntax for TypeScript, again, they have really good documentation on this, and we're going to go step by step, is to do something like A equals string, or in our case, it's a number, and B should also be a number. I'm going to add spaces here just to make it cleaner. All right, if I save this now, and watch this, as I hover, do you see how my editor is giving me a little hint? That's another benefit of TypeScript. It's going to help me with some hints as I'm working on my code. But for now, let's see what it compiles to. I'm going to run it again and go to my JavaScript file. And yep, we don't have any of this number stuff. The compiler takes it out because this is the code that's going into production. And we don't want these extra bytes in our code that's going to make our code heavier to send to the client. So the compiler does this automatically for us. Very cool. But check this out. If I do sum 4 plus 5, whoa, what did I just do? My editor automatically, I didn't do anything other than have my TypeScript set up with my editor. I get expected 2 arguments, but got 1 because I'm doing 4 plus 5. Again, if we do 4 comma 5, now everything should work. And I'm not getting any errors. If I save and run TSC, everything works. Our code is still working. If I console.log, and let's just give it a const answer, and we'll just console log the answer. And let's run this again. All right, everything is working, but if I do node TypeScript.js, I get the answer of 9. Very cool. What if I do a string saying hello? Do you see that my editor has an underline of red now? And if I hover over this underline, kind of like a spell checker on your Word or text document, it says argument of type hello is not assignable to a parameter of type number because I've said that A has a type of number. Even if I try to run TSC now, oh, I didn't save it. Let me save that. Even if I run TSC now, it actually will throw an error saying that exactly what it said in my editor, that type of string isn't going to work with type of number. How cool is that? This is what we mean where we say that it catches errors at compile time. Because this code will never make it out to production. Because in order for us to send code to production, we must first convert it to JavaScript. And when we convert it to JavaScript, we catch those errors in our compiler. And if it throws any errors, we know we need to fix them. Versus JavaScript, the way that it works is this JavaScript gets sent to the browser, and the browser does what it's called a just-in-time compiling, and compiles the code on the spot for each one of their users. And this will most likely throw an error. And the user might see a blank screen or a red, and we wouldn't know what to do. So that's pretty nice. And by the way, you may have noticed that it still compiles our JavaScript to the hello string parameter. That's just something that it does, but you can see here that the errors do come out so that you wouldn't actually send this to production. You'll see that there's errors and that you need to fix some stuff. All right, this looks pretty exciting and promising. We just had this great feature added to make sure that our code is less error prone. Go try it out on your own. Make sure that your text editor has all of this set up. And keep in mind, if you're having issues with your editor, Google is your friend here. There's a ton of resources online for whatever editor you have to set it up with TypeScript. But it shouldn't take you more than a couple minutes, maybe max an hour. All right, I'll see you in the next video. Bye-bye. Welcome back. We just wrote a few lines of TypeScript code, but the one thing that was kind of annoying was that we had to constantly run this command to compile our code. Ideally, we can just have that running and done automatically. And the way we can do that is quite simple. We can initialize our project as a TypeScript project by simply running tsc --init. We see that it's created a tsconfig.json file. If we go to this file, we see that it's created what we call a configuration file for TypeScript. And you can see over here that this file gives us a ton of option for the compiler to check. And the compiler options can do many things. We see that our target is ES5, and it says specify ECMAScript version. And you can see how many defaults they have. So for example, if I change this to, let's see their options that they're giving us. Let's change it to ES 2017. So I'll say ES 2017. What kind of modules we want to use. We can do CommonJS, or perhaps we want to do ES 2015, and a ton of options. You basically can decide what kind of work you want the compiler to do and what type of output we need. And the great thing about this config file is that it actually describes every little thing that you can do. Online, you also have a great documentation on tsconfig file if you want to get really into it. But don't worry, later on, I'm going to show you how to actually simplify this step, or how it's already been simplified for us. For now though, we have a tsconfig file, which is the default setup for now. If we go to typescript.ts, so we just cleared our terminal, and the way we are able to run this in watch mode is quite simple. All we need, not here. All we need is tsc typescript.ts and then --watch for watch mode. And you can see over here, it's starting compilation. Compilation is complete, and now it's watching for changes. And every time I save, it's going to recompile and detect these changes. For example, if I change this now to a Boolean value, it's going to give me an error in the compiler and says, you're doing something wrong here. All right, so we have this running and everything's set up. I think it's time for us to go through all the types that TypeScript give us and do a bit of coding. So get that set up on your computer, on your machine, and I'll see you in the next video. Bye-bye. All right, let's start learning some of the different types that TypeScript comes with. And we're going to take it one by one. And don't worry, you're going to have access to this file at the end of this video, so you can use it as a reference. The first thing is a Boolean type, a true or false. And that's very easy to do. We can just say let is cool be a Boolean type. So you always see the syntax, the semicolon, and then the type that we want it to be. So in our case, we can just say true. And everything is working fine. We have a Boolean type. Again, just to prove that it works, you see that we get an error now every time we do something other than Boolean. All right, that was easy. What's next? Well, we've seen this one before. Let's do a number type. And by the way, you notice that because this is a TS file, a TypeScript file, let me close this. Because this is a TypeScript file, we see that we get some highlighting. If this was in JavaScript, it wouldn't work, but because this is a TypeScript file and my editor is set up with TypeScript syntax, it has nice highlighting for me. All right, number. This one, again, is fairly easy. I can say that let age, which is a number, equals 56. Nice and simple. Save. And just to double check, if we go to our JavaScript file, we see the output. All right, I'm going to close the config file here because we don't need it. The next one is obviously a string type, another one that we've seen. And this string type, let's say, is let iColor be a string. And we'll say that this equals brown. Perfect. And we save. And everything works. And by the way, this works with ES6 template strings as well. Let me show you. I can do let favorite quote, for example, be a string. And this string is going to say, I'm not old, I'm only and the age that we defined up here. So if we save that, you see that that still works. No errors with our compiler, and we have everything outputted correctly. So it detects template strings as strings as well. All right, not too bad so far, fairly easy. What about arrays? Well, with arrays, we can do let pets, and let's say it's an array of strings. Well, we can do strings and then the array symbol. And we simply do equals, and we'll just give it an array. Nice simple array of, whoa, cannot type right now. Cat, dog, and let's do pig. Save. And ooh, I get an error. I said that says cannot find name strings. And again, a little bit of a misspell. You see that I have the underline here. Cannot find name strings. Thank you, TypeScript. This should have been string. Save. Perfect. Again, another great thing that I keep mentioning with TypeScript is this ability to constantly tell you whenever you're making the mistake before you even run the code. There's actually another way that you can declare arrays with TypeScript. And let me show you. Let's do pets2. And I can do it this way as well, which is actually my preferred method. Array string like this. And that's the same thing as the above. So in here, I can say that this is a lion dragon, some scary pets in here, and a lizard. Save, and everything still works. All right, well, the natural progression, I guess, is maybe to test objects. So let's say let wizard equal an object. So let's say in here is just going to have a John. I save. I get no errors because I haven't declared any types. But in here, if I say object and save, all right, everything still works. If I make wizard equal to 5, I get an error. We're expecting a type of object. All right, that's working. And you notice here that it's lowercase object because uppercase object you can use in JavaScript, right? You can do object.keys and so on and so forth. So you got to make sure that this is lowercase object. And we're going to get a little bit deeper in objects in later videos. Don't worry, because with objects, types do get a little bit more complicated. All right, I think that's good for now. These are our basics. There are a few others that I want to cover. Actually, you know what? Let's do, just to cover our basics, let's do null and undefined as well. And null and undefined, again, so far it's been pretty easy because they're named exactly like they are in JavaScript. We can say let meh equal undefined, and that's going to equal actual JavaScript undefined. Again, everything is compiling perfectly. And if I go ahead and do let no equal null, and that equals actual JavaScript null, because remember, this is a TypeScript type. This is the actual JavaScript value. If I save, everything still works. All right, so that was extremely easy, super easy, because we've just used everything that we already knew in JavaScript. But the power of TypeScript is that we get a few extra features that JavaScript doesn't have. Remember, it's a superset of JavaScript. So in the next video, we're going to learn some of these new types. I'll see you in that one. Bye-bye. Welcome back. Let's learn a few more types that we can use with TypeScript. The first one is something called a tuple. And by the way, where do these types come from? Well, some programming languages actually have these types that we're going to be talking about. And JavaScript just happens to not have them. Doesn't mean it's a bad thing, but TypeScript allows us to actually use them, which is a pretty nice feature. So a tuple is, well, I think just showing you might make sense what a tuple is. We can say let basket be string and number. And now the basket will have a basketball and a 5 in its array. So if I save this, everything still works. And that's a tuple. A tuple you can define in this syntax and have different types inside of it. So that if for some reason my order changes, and I do 5, and now basket, let me make sure I add the string, I get an error because it's expecting this specific type and this type order. And it can come in very handy for certain things. You might not use it that often, but just again, like I said, just an extra feature you can use. Another one that's very popular, especially because it exists in a lot of programming languages, is something called enum, for enumerable. And here we can do something like this. We can say enum size. You see that we get that highlighting. So this can be anything that we want, and usually capitalize it. And we'll say with curly brackets that small equals to 1, medium equals 2, and let's say large equals to 3. And now, using this enum type, I can say let size, let's say size name, be a string, and say equals size 2. What does that mean? Let's save and see what happens. I'm not getting any errors. So it looks like it's working. I'm getting no errors. But if I go to TypeScript.js, whoa, I'm getting some funky outputs here. But it looks like the size 2 that I'm getting should output medium. Let's test this theory. I'm going to say console.log size name. I'm going to save. I'm going to close the compiler for now and just run node TypeScript.js, and I get medium. I know this can get a little bit confusing, but again, something that you can read up on. With enums, you can have a different data structure that you can use to organize your information for your program. For example, if we had a shopping cart and we had small, medium, and large sizes, and each value of the small, medium, and large was 1, 2, and 3, well, we can use size name to make sure that we get the correct value. Now, let's say we want to have, instead of size 2, let's say we're going to have size small. If I run the compiler, type small is not assignable to type string. But if I change this to number, everything works because size small is now equal to 1. And you can see if I hover over this, it shows me that size small is equal to 1. Now, when would this be actually useful? Well, enums allow us to define a set of named constants, just like we have here. And using them, we can make it easier to perhaps document intent or create a set of distinct classes such as sizes, or perhaps maybe we want to have directions like up, down, left, right, and each direction has a value associated with it. Again, you can read up more about it on their documentation. It's just another useful tool. All right, let's take a break and I'll see you in the next one. Bye-bye. Welcome back. I'm going to show you a type now that, well, I don't recommend using, but it's still there. It still has some use cases, but please be careful. I'm going to do some exclamation marks here because this is something that if you're using it, you want to make sure that you're using it right. And that's the any type. Let me make more space over here. We can say let whatever be of any type. And let's be dramatic over here. No. If I save, it works. And whatever can be whatever we want. For example, I can say whatever equals to 5. Oh, I can't spell. All right, no compilation errors. I can do true. I can do, let's do size.small from above. All right, that works too. And I can even do, let's say, whatever equals basket, which is the tuple from up here. And no errors. You see, any type, as the name suggests, can be any type that we want. And you're thinking to yourself, so what's the point of any? I mean, Isn't JavaScript just pretty much the any type where we don't have static typing? Why would you ever want to use this? And you're right. By using this, you're neglecting all the benefits that TypeScript would give you, because whatever will never throw out an error. It can be whatever we want. But any is useful for cases, let's say, where you're working on converting your code, your JavaScript code, into TypeScript code. And that might take a long time. And in the meantime, you might want to just place any for really complicated functions or really complicated objects that we can't right away define them like we have here. But again, be very cautious. You're pretty much not using the benefits of TypeScript at all. So if you have any all over your code base, then you're not really using TypeScript properly. Another interesting one that we can learn about is something called void. And void is quite common when we're working with function. Let's say we had a sing function, and this sing function doesn't return anything. It's just going to have console.log. Or just to be more expressive, we have no return statement here. We're just going to do console.log. La, 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 la. Beautiful song. Now, in here, if we add types to it, because this function isn't returning anything, we say void for nothing returned. And you see that it's not failing. If we do return something, let's say that we return la la, we get an error because we're expecting no return, but we are indeed returning something. Again, we get that nice hint from TypeScript in our editor. So now if we're returning la la, I can just say string and everything works. But let's keep it the way it was, using void for any function that doesn't return anything. There's also a type of, again, let's make more space, of never. Now this is a tough one. What do you think it does? Let me show you by code. We can say let error equal to the error function that simply throws an error. Oops. If I save this, nothing's happening, but if I give it a type of never, there you go, it passes. So it recognizes the type of never. If I do void, it still works because we're not returning anything. But if I do something like string, it's working as well. So what does that mean? Never type actually tests two things. One is that a function never returns. And the other one is that a variable under some sort of a type guard is never true. For example, in our case, when we throw an error, TypeScript infers the never type because the function neither has a return type nor a reachable endpoint. So this works. And if I do return hello and I save, I get an error. We get an unreachable code error. But if I bring this, or hold on, make sure we get this to never, we go up and save. And we see that we get two errors. One for unreachable code, which that makes sense. And type hello is not assignable to type never. If I comment this out and save, again, I get that error once again because we're returning something. Let's go back to the error and everything is compiling properly. You might be wondering, what if I put never in here? Save. We see that a function returning never cannot have a reachable endpoint because this function runs and has an endpoint. It does console log and then it ends. So remember, never is for a function that doesn't return and doesn't have that endpoint. Usually throws an error. All right, that's it for now. More types in the next video. Bye-bye. All right, let's keep going with new types. Another one I want to show you is a very useful one called interface. And interface can be used really, really well with objects. Let's have a look. I can say interface robot army. And this robot army, and you see the capital letter here, is just the standard with an interface that we have capital start to our names. And let's just say that the count is number. The type is string. And let's say magic is string. So robot army has 3 properties. So that now if I'm using this robot army, let's say I have a let fight robot army function, and this function has, let's say, a robots parameter that it receives that takes robots that have of type robot army, so interface robot army. And here we'll just say console.log fight. Now, what did I just do here? This makes sure that this robots parameter that I'm receiving is going to have a count, a type, and a magic property. Otherwise, it's going to throw an error. And you might be thinking to yourself, this might be useful for React and props, and you'd be right, as we'll see later on. So that above is the exact same thing as saying let me just copy this. That's the exact same as saying that we want the robots to have a count of number, a type of string, and a magic value of also type string. So let's make that a little bit smaller. That's what we're doing up here. Except with an interface, it allows you to have objects like this that create a new interface that allows us to make sure that certain objects have certain properties. So if I save here, see, I get a bit of an error. Let's see what it's here. Completion. Oh, and I have an error here because I'm using the same variables. Let's add 2 here. And there you go. Everything is working. So interfaces are extremely, extremely useful. It's kind of like we're creating a new type here, right? I mean, TypeScript doesn't have a robot army type, but we're creating it. We're creating an interface that says, hey, from now on, this robot army can act as a type that has these parameters that we've set for it, which is very, very cool, very flexible, and that's why interfaces are used a lot. Now, in React applications, you're going to see interfaces a lot. And you might also see this other way of using this type keyword, which also works. If I save here, if I save this and I have to give it an equal over here, everything still works. Now, there's one difference between interfaces and type. And I know the name gets confusing between the property that I just set, but don't worry, they're different. The one difference is that interfaces create a new name that we can use everywhere, such as the robots army. Type aliases, as we like to call it, don't create a new name. And it has a few other features that you can read about. I always recommend using interfaces because it's a cleaner syntax and a better error output. All right, that's it for interfaces. Let's save and make sure that our errors are completely gone, and I'll see you in the next video. Bye-bye. Welcome back. Let's talk about a topic in TypeScript called type assertions. Now, type assertions in TypeScript allows you to override a type in any way you want. And this is done through this mechanism, type assertion. In plain English, it's simply saying, hey, transcript compiler, calm down. I know what I'm doing. This is the type that I want. Don't worry about anything or second guessing me or printing out an error. I got this. I'll tell you what kind of type it is. So let me demonstrate for you what it would look like. If we go back up to here with the robot army that we had, and I copy this robot army instead of robot army, I'll call it, let's say, a cat army. Let's say that we're creating a object. Let's call it let dog equal to an empty object. If I try to access dog.count and I save, I'll get an error. Count does not exist on type empty object. But if I do something called type assertion, and let's just comment this so we have a nice reference for it. If I do this, I can say empty object as cat army. And if I save here, whoa, look at that. No errors. I'm saying, hey, dog, I'm telling you that don't worry about it. This is a cat army. Regardless of the fact that dog actually doesn't have dog.count, I'm overriding whatever error you're going to give me and telling you that, trust me, this is the cat army. And obviously, this is very dangerous. And it's something that you want to be really careful about using. But there are cases that we'll see when you might want to use this. So TypeScript allows us to do this type assertion. By the way, you might be thinking to yourself, what happens if maybe the robot army sometimes has magic, sometimes it doesn't? This is an optional property that not all robot army objects have. What can we do? Well, we can just simply say question mark. And now question mark says this may or may not be part of the object. If we do fight robot army with an object that is count of 1 and type of dragon, a dragon robot army, and I save, and I make sure that I don't have this array over here, everything still works because I have this question mark. We may or may not get the magic property, but count and type do need to happen. If I remove this and I save, I get an error. It's expecting a magic property. All right, I'll see you in the next one. Bye-bye. Welcome back. Let's finish off our types. And remember, there's a few others, but you can take a look at the documentation for you. I've shown you the types that you're going to use 90% of the time. So these last ones, function and class. Let's take a look at function. And a function can be quite similar to what we've already done, right? Let's say that this fight robot army now, and let's call it fight robot army 3 so that it doesn't complain that it's the same variable. We can say that the way you declare the functions is, well, we have the robot army, but also that the function returns void because we're not returning anything. And we've seen this before. So if we do the same thing for the above, we can scroll down, fight robot army 4, and once again, I know this is getting long, but let's make this a little bit smaller. This again would return void. If it returned, let's say, a number, let's say it's going to return 5, we could have said number here. And it looks like everything worked out well. And this is when you start to see that, all right, it's getting a little bit confusing with TypeScript adding all these types. You kind of lose track of what is going on in a function. And if you are not comfortable with TypeScript, it's really hard to be like, I have no idea what this function is doing, what the parameters are doing. And that's one of the drawbacks with TypeScript. It's an extra layer of complexity that your apps now have. All right, that's pretty easy. We're pretty comfortable with functions. So let's talk about the last one, which is class or classes. Let's say that I had an animal class. And this animal class will have a sing property that is a string. And let's also have a constructor that has a sound of string. And we can say that this.sing, and we're just using class syntax here, is going to equal sound. And let's just say that sing is going to be la 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 la. Now we'll also have a function or a method called greet. And this greet method is going to, let me scroll down here so we can see better, is going to return a template string, hello, plus, or we don't need the plus, we can just say hello, and we'll add the this dot sing property. And let's close off with the backtick. All right, so now if I go, let lion be a new animal that takes in the sound of, let's say, roar. I think that's how lions go. And I save this. Let's go over here. All right, we're not getting any errors, which is great. And let's run lion.sing or lion.greet. And if I run this, no errors, and I do greet, I should have the hello la 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 from there. Just to test that for fun, I'm going to go to my JS file, scroll all the way down, and just console.log my lion greet. I'm going to save. Let's close that compiler for now and run our node script, and we see hello roar with our compiled JavaScript code. All right, let's go back to our TypeScript file. So this is working, but here's the interesting part. What if I do sing? Or, hold on, sing is a property, so let's just grab the sing property. We see that we're able to grab the sing property from here. All right, but the cool thing you can do in TypeScript is I can set this to private. And if I set this to private and I save, I get an error. I'm trying to access a private variable that I shouldn't have access to. Very, very cool. By the way, by default, this is set to public, as you can see here. Again, nothing too crazy. We have a good idea of our types. If I do greet, and it's going to return a string or a string, and I save, that also works as well. So we should feel pretty comfortable with classes as well. All right, that was a lot. We see here that we wrote a lot of TypeScript, and it's all compiled into a little bit of a messy code on JavaScript end, but we don't need to worry because TypeScript makes sure that we output code that works. I'll see you in the next one. Bye-bye. Welcome back. All right, don't get mad at me, but I lied. There's one other type that I need to show you, and it's a new feature in TypeScript, and it's called a union type. This is a very simple one. A union type is, well, let me show you. It's let confused And I'm confused because this variable can be a string or a number. How do we do that? Well, with a union type. And you can see this. This is the shift and the button right above my return key on a Mac. It's this little line over here. And I can say it can be a string or a number. And I can say equals hello. If I save this, everything still works. If I do, if I change this to a number, like 5, it still works. But if I change this to a Boolean, like true, it will fail. I was able to say it could be this or it could be this, and I can keep chaining them. I can say this is also a Boolean, and that works as well. Nice and easy union type. It can be quite useful. I'll see you in the next one. Bye-bye. I wanted to add a quick note with this video, and that is in TypeScript, there are several places where type inferences are used to provide type information, where there's no explicit mention of a type. What do I mean? Well, TypeScript is smart enough to know or infer and say, yeah, you mean a number, or yeah, you mean a string, and actually add types for you. Let me show you what I mean. If I go let x equals to 3 or 4, and I save, and let's just say I'm going to go x equals to hello now. Well, look at that. I get type hello is not assignable to type number. Even though I never said number here, it inferred and said that, oh yeah, you're just giving me a number, that's easy. X is supposed to be a number. And that's a really nice feature that you get out of the box without doing anything. So we have gone through all these features of TypeScript. Very cool. All right, I'll see you in the next video. Bye-bye.